Hello, my name is Harsh Patel, and this is the video presentation for the final assignment of Applied Machine Learning of the semester. And in this assignment, I'm going to use the dataset chest X-ray images, which is one of the most popular datasets on Kaggle. And the reason I selected this database is mainly because of its popularity. Uh, I went to datasets and I just selected anything that had size of 1 GB or less than 3 GB, and I just sorted them based on how many votes they have received. And this is the first data set that I got. It's pretty popular, and it's around 2 GB in size, and it has three directories: test, train, and validation set. So basically, you just have to download it, and then you can use it for your project. And so I downloaded it and I saved it inside Colab notebooks, just X-ray folder. And then I'm going to connect my Google Drive with the Colab. And this is the base directory that the images are stored in my drive, which is right here in my drive under Colab notebooks under chest X-ray. That's the base directory. Train directory will be the data set which is supposed to be used for training. Validation directory under val and test directory under test. Then I'm importing layers and models from Keras. Now moving forward in the next command, I'm creating my model, and in the convolution set I have 8 layers, which consist of con2d and max pooling layers, and after that I have 2 more dense layers. Now before applying dense layer, I need to flatten the output that I get from convolution part. Because dense layers will not be able to accept the 3D output that Con2D provides. So we have to flatten it, and then we can apply dense layers after that. You can always check how your model looks like using the model.summary command. In the next line, I am importing optimizers, and then I'm compiling my model. After that, I'm importing image data generator so that I can rescale the images by dividing all of those images by 0.255. And the reason I'm doing that is because it's easier for our network to process them if they are smaller in size. And as you can see in the training data set, we have 5,216 images, which belongs to 2 classes, 16 images in the validation data set. And in this command, I'm using my model to train the data set, and over the course of 10 epochs, the accuracy that I got is 98%, and the validation accuracy that is applying our model on unseen data, it's 93%, which is pretty high. I did not expect it. You can always save your model using model.save command, and after you save, it's gonna appear in this content section right here. Now, in the second half of the code, we are going to use a pre-trained model to improve the accuracy on the same data set. So I'm going to import VGG16 from keras.applications.vgg16, and I'm going to download a convolution neural network which already exists, and I'm going to use that to improve the accuracy of my previous model. After downloading, you can always double check how the model looks like using .summary command. Now I'm doing as usual the same steps. I'm importing image data generator, and then I'm rescaling. And then in this command, I'm using the extract features. Now what extract features basically gives us is that they give us new features which are a linear combination of the existing features. However, the main aim is that fewer features will be required to capture the same information. Now, as you can see, we have 5,216 images in training, 16 in validation set, and 624 in the testing set. Moving forward, I'm going to reshape them using np.reshape command, and then I'm going to design the model. for which I'm using one dense layer, one dropout, and then another dense layer. And after compiling the model, now after using history is equal to model.fit command uh, to use the model for training my data set at the end of over the course of 20 epochs with batch size of 20, the accuracy that I got was 99% and the validation accuracy is 93%. If I compare it with the previous model, there's definitely an improvement of like 1% in terms of the main accuracy. However, the validation accuracy did not change much because I did not expect the first model to perform as good as the second one, but that won't be the case all the time. So definitely using pre-trained convolution neural network to improve the features, it's going to improve your accuracy certainly. So that's all for the explanation of my assignment. Thank you for watching.